Okay, so at the end of the last video, we found the volume of this prism by finding the area of the base and then multiplying it by the height of the prism. And then we're going to try that again here with part D. We are going to try to find the area of this hexagonal base, and then we're going to multiply it by this height of 7. Again, trying to reinforce this idea that volume is really just like a stack of the shape. It's like a repeated stack of, it's 7 inches high of hexagons. It's that same shape being stacked on top of each other. So if we find the area of one, we can just multiply it by the height and find the area, or really the volume of the whole thing. All right, so we got to find, this one takes a little bit longer because we got to find the area of this hexagonal base. And so I put down on here this hexagon. It says in the problem that we have a side length of 4 inches, which means down here is 4 inches. Just like if we want to find the area of any polygon, we got to turn it into a triangle. We need to find the central angle, so we got to find this angle right here. To find central angle, that is 360 divided by the number of sides. This is a hexagon, so it's got 6 sides. And so my central angle is 60 degrees. We drop the apothem down. The apothem does two things. It cuts the central angle and it cuts the side length. So this is not 4, but the whole thing is still 4, so I guess I could leave that in here. The whole thing is still 4, but it breaks this down into 2 and 2. Whole thing still being 4. And we know that central angle inside is 30 degrees because it got cut in half, was 60, got cut in half. All right, now all we need to do is we need to find the height of this triangle that I'm going to call x, and to figure out what that x is, we have to use trigonometry. All right, we have, that's 30 degrees up here. We have 30 degrees as my angle. Across from it, or opposite, is the 2, and the x is the adjacent. The x is the adjacent because it's between the angle and the 90 degrees. And so if it's opposite, adjacent, it's a tangent problem. So to find x, what I'm going to do is the tangent of 30. And that's going to equal my opposite, which is 2, over my x, which is x. That sounded kind of funny. Okay, now I have to solve this for x. I put tangent of 30 over 1 and I cross multiply here. 1 times 2 is 2. The tangent of 30 times x is the tangent of 30 times x. I divide both sides here by the tangent of 30, divide by the tangent of 30, divide over here by the tangent of 30. That's terrible handwriting, my apologies. And I should have my answer for x. Let me bring up my calculator quick. 2 divided by the tangent of 30 gives me 3.46 as my height. All right, so now I can find the area of my triangle because I now have a height and I have a base. And so to find the area of my triangle, it is 1/2 base times height. My base was 4, my height is 3.46. So the area of my triangle is 1/2 times 4 is 2. 2 times 3.46 gives me 6.92. All right, that's the area of my one triangle. This hexagon is made up of 6 triangles. So I take my 6.92 and I multiply that by 6. Let's make sure I get this right. This would give me 41.52 as the area. So now I found my area of this base. I found the area of my base down here. That base just keeps getting stacked on top of each other for 7 more times, or 7 inches. And so I take that base, that's 41.52, and I multiply that by 7, and I come up with my answer for the volume. And I should put, I want to kind of change this so I don't like this. I want to say volume equals my area of my base times my height, and that gives me a volume of 290.64 And I believe we're working with inches, and so this is inches cubed because it's a volume. So 290.64 inches cubed is my volume. Again, I'm trying to reinforce this idea that really what we're doing here, and this one took a little bit, we find the area of our base, we can just multiply that area by our height. All right, and we'll see that again here in 9-30. 9-30, we finally see our first cylinder, and it's really asking this basic question is, do things work the same? Can we find the area of the base and then multiply it by the height, even if the base is circular? And the answer is yes, we can. And so we're going to do the same kind of thing we did in 9-29. We find the area of the base, we multiply that by the height. All right? And so what we need to do is we need to find the area. We have a circular base, and so we need to find the area of that circle. Well, area of a circle is pi times the radius squared. It tells me that my radius is 5 units, and so I can find that area of that circle, which is pi times 5 squared, and my area is equal to 25 pi, or if you like decimals more than you like the 25 pi is the same thing as 78.54 if I round it. So either way, that's your area. And then to find your volume, you take your area and you multiply it by your height. And so you could do either way here, no matter how you like to do it. You could take the 25 pi, you can multiply that by 8 because our height is 8. And if we do it like that, 25 times 8 is, so we'd get 200 pi as a volume. 200 pi units cubed is our volume. Or another way you could write your volume if you like it in the decimal form is to do the 78.54, multiply that by the 8, and get a volume of 628.32 units cubed. Those probably are the same answer, maybe a little bit off because of rounding, but either way you like to do it. Again, I want to really hit this idea home here in 9-30 that it doesn't matter if the base is a hexagon, if the base is a triangle, if the base is a square. If you find the area of the base and then multiply it by the height, you get your answer for volume. Okay? Moving on to 9-31. This one's a little bit quicker because A and B are quick. So there was a mathematician, Cavallari, that had this idea. And it's really this idea is, does the volume change if we start tilting our shapes? If we tilt, kind of like we see here, if we tilt our cylinder, if we tilt a hexagonal prism, and they give us different examples. It says, if you stack 25 pennies on top of each other, and then you slant that stack by sliding some of the pennies over, does the volume change? And the answer to it is no. All right? So it's a little quick, I get that, but the answer is no. The volume does not change when we start slanting it. Because each individual penny holds the same volume. Just because we're slanting them, it doesn't change the volume of the pennies, and so it doesn't change the volume of the stack because nothing's really changed. And in B, it's going to be the same thing. All right, it's saying, what about if we stacked 15 books, or if we slide them, or we twist them, or if we did the same thing with 1,000 sheets of paper? It doesn't matter because we're not changing the volume, the individual volume of the books, or the individual volume of 1,000 sheets of paper. And so it doesn't matter if we twist them or stack them or like slide them over when they're stacked. The volume remains the same. And so then when we see a problem like we do in C here, so B and A are just kind of like no, with that quick explanation from me. And you could say, like, would the same thing be true for a stack of 15 books? Yes, the same thing would be true as in A. The volume doesn't change. So if you want an answer, you could say, yes, volume does not change. Volume does not change. I don't know. However you want to say it in your own words. All right. Now we have this one here, and this is just an example. So it's like the same cylinder we just saw. It has a circle with radius 3 and a height of 8. And then the question asks us, how does the volume of the prism change? Well, I just said, and I want you to understand it too, that the volume does not change when things get slanted. So if we want to find the volume, we do the same thing. The area of that circle is still 25 pi. The height is still 8. And so our area, or our volume becomes 25 pi times 8, which gave me that 200 pi. Again, just trying to reinforce this idea that nothing changes if we start slanting it. We are going to wrap this up with one last problem, 9-32, a problem that I love, a cool application problem. We have to replace a hot water tank, and he estimates that his family needs a tank that can hold 75 gallons of water. His local water tank supplier has cylindrical models that have a diameter of 2 feet and a height of 3 feet. And so what that looks like is we have this cylinder here. We have a cylinder here, and it has a diameter of 3 feet, a diameter of 2 feet, and a height of 3 feet. It says if 1 gallon of water is approximately 0.1337 cubic feet, determined if the supplier tank will provide enough water. So we need to see if this tank can hold at least 75 gallons of water. And so we got to find the volume of it, and then we'll divide that by the cubic feet to see how many gallons it will give us. And so if we want to find this volume, we need to find the area of the circle, multiply it by the height. I know the diameter of this circle is 2, which means the radius is equal to 1 because the radius is always half of the diameter. And so then I can find the area of my circle. The area of my circle is radius squared, pi times radius squared, so pi times 1 squared. And so my area is just equal to pi. And then I have this height of 3 feet. And so for volume, I take my area, which is pi, and I multiply it by 3 for the height, and I end up with a volume that is 3 pi, and that would be, this is feet cubed, and if I want to write as a decimal, which I kind of do in this one actually, I'm going to do 3 pi and say that that's actually 9.42 feet cubed for a volume. All right. So my volume is 9.42 feet cubed. It says that for 1 gallon of water is 0.1337 cubic feet. And so what I need to do here is I can say that I can take my amount of feet that I have here, my cubic feet, 9.42 feet cubed. I can divide it by how many cubic feet are in a gallon. So I can divide this by the 0.1337 feet cubed, and I can come up with my answer. And so I have 9.42 divided by 0.1337, and it gives me an answer of, I'm going to put it down here, it gives me an answer of 70.46 gallons that tank can hold. All right. I want to show this kind of as a stoichiometry. I didn't know if I really had time to, but I do here at the end. But before I do that, I do want to say that that tank will not work because he needed to hold at least 75 gallons of water, and it looks like this tank can only hold 70.46. All right. So in my last minute here, I'll show the stoichiometry for you chemistry fans. Stoichiometry here, we had 9.42 feet cubed. We can put that over 1. And stoichiometry is always about multiplying to cancel things out. So we multiply here, and we say that, well, for 1 gallon, that would hold 0.1337 feet cubed, or cubic feet. And then when we multiply these together like I did, what's going to happen is we're going to go from this stoichiometry state where we're multiplying it to up here, which look like this. And what's going to happen is your feet are going to be canceling here because you have feet on top, feet on bottom. You're going to be left with just gallons. And again, reinforcing that we got 70.46 gallons. All right, that's all I got for this video. If you have any questions, make sure to email me.